So in experiment number 12, we're going to use spectroscopy to actually decide what's in a particular solution. Now, what happens in spectroscopy is basically light passes through a solution, and the more substance that's in there, the more light will absorb. But not only that, when you have different colors, remember that white light's made up of the entire rainbow, but when you see a color, you're seeing the colors of the substance that's actually being reflected, not absorbed. So we're going to actually use a spectrometer to help figure out what wavelengths the particular materials are absorbing, and then we can actually decide what's in them and also decide which one's contaminated. So we have a bunch of food coloring dyes that we're going to use. We have red, green, yellow, and blue. And then we also have some sports drinks that also have some of these materials in them. Okay, and you can kind of look and kind of guess the particular dyes that are in there, but we're going to use spectrometer to prove which ones are in there. And then also one of these sports drinks has been contaminated with copper sulfate. So we should be able, through spectroscopy, to figure out which one that is. Okay. So we have our veneer set up. This is a spectrometer right here. Okay. And we use a cuvette. Now on cuvettes, they have a rough side and a clear side. You always want to make sure the clear side is facing the spectrometer, and you want to try to make sure there's no air bubbles in it. And so right now what I have is just distilled water in here. And this is our blank. Okay. It's being very ornery with the air bubbles. So we're supposed to put this in, and then we're going to go and hit calibrate on the instrument, and that should be under the experiment here. And we're going to go to, helps if I can find calibrate. There it is, it's down there. So here's calibrate, and we're going to calibrate spectrometer 1, and it says it's going to tell me that it's waiting 90 seconds for the lamp to warm up. And once it does that, what it's doing is it's taking a spectrum of the cuvette and the water, so that whenever we look at any other ones, it'll subtract that portion out. Okay. So it's finished its warm up, so now we're put the blank cuvette in there and we're going to finish calibration. And I hit OK. Yeah. So now we're ready to do our samples, and we'll start with the red food coloring as the first one. And so we place it into the spectrometer. And we're going to hit collect. And notice you see a peak showing up there. It's actually absorbing in the green area, even though the material is red, because it's reflecting red. Okay. And then we'll go ahead and hit stop that. And so we'll record that we have a peak at about 510 nanometers for that red dye. So now we'll go to move to our second one. Wiping off the container here. This is the green food coloring. And once again, we go to collect. I'm going to store our last run. And now we see the second one, which is the green food coloring. And notice the green food coloring has two peaks. And we'll stop it so we can read what those peaks are. It has this peak over here at about 629 nanometers. And it has a peak over here at 413.8 nanometers. Okay, so you can see the two together there. If we go to the yellow food coloring, clean off our cuvette, place it into the spectrometer, and we hit collect. It's going to ask me if I want to save the last one, which I do. Okay, let's save it. And so now you see where the yellow is showing up. It's off to the side there. And when you hit stop, you get a nice peak on this one. And the yellow has a peak at about 429.3 nanometers. One last food coloring for us, and that is the blue food coloring. And in the blue food coloring, we gotta get rid of that air bubble. Put that in. Yeah, this one doesn't have sides, okay. We hit collect on the blue food coloring. We'll store our latest run. And notice the blue is very interesting, very similar to green in a way. And if you know anything about art, that makes sense. We have a peak over here in about the same region, but we also have a peak over here, a little bit of a hump at 408.3, a little bit of a bump at 494.5, and then of course the largest peak is at 629.9 nanometers, and that was the green. So the only other known that we have is our copper 2 sulfate. This is the contaminant that's in one of our sports drinks, and we're ultimately going to find out which one has it by using spectroscopy. So we place our copper sulfate in there, and we're going to take a spectrum of it. And notice how that is a very, very distinct peak. It should be very, very obvious when we see the contaminated sports drink, because it's over here all the way actually out of the range of the spectrometer. It's about 808. So any of our sports drinks that has that peak, we definitely know is the contaminated one. Okay, so let's go ahead, store this. We're gonna store our latest run. Where's the store? Store latest run. And now what we can do is we're gonna go ahead and hide the data sets that we already have so that we can look at the new sports drinks. We don't want the things to be in the way. So we hid run 1, we'll hide run 2, we'll hide run 3, whoops. We'll hide run 4. Now, these data sets are still here so that I can do a comparison later if necessary, but I don't want them showing up when I do the sports drinks. I want the sports drinks just to show up on their own. And then we're ready. So we move to our sports drinks, and the first one we'll do is what's called Sport Drink A. Okay, and notice it is yellow in coloration, so you would expect to see peaks from the yellow dye in there, and perhaps something else, and we'll find out. So we'll go ahead and hit collect, and notice you do see this nice peak here. We'll hit stop. You see this nice peak here at about 431. Okay, and if you were to go ahead and compare that to your yellow dye from the past, it should compare pretty well. If you look at the unknown B, which is red in coloration, okay, that should obviously have some red dye in it, but it might have something else in it too. So we'll look and we'll see what that one looks like. We'll store our latest run there. And this one, okay, so notice it's not on scale. If you want to auto scale these, you hit A, and you can still see it's a little bit off scale. It's absorbing very, very well. But it is, I would say, if you were to estimate its peak, it's probably about 487.3. There's a peak there, and maybe you have a little bit of a shoulder here at 536.9. And so that's a little bit different than the ones we've seen. There are different types of food dyes. If you ever read like Red Dye 40, things of that nature. So it could just be a different variety. Now we're going to our sports drink C, and we'll see what that one looks like. And with unknown C here, we have a nice peak here. And when you look at this, we'll stop this for a minute. You've got a slight small peak here at about 408.3, a very distinct peak at 630.7. And then notice, this is the first time we've seen a peak out in this region, and this was the region that we saw the copper sulfate before. So perhaps this is our solution that has copper sulfate, because I do see a peak out in this region in the 800 region. And finally, we do our unknown D sports drink, which is greenish in coloration. I'm not going to say it's green, because you'll notice that the green colors are very kind of different. So it does have some other substances in there, and maybe we'll be able to tell which ones by taking our spectrum. So let's go ahead and collect that. And so when we do this one, we see that we have a peak that looks like it's about 436, which we have seen before. Actually, it's 431.3. We've seen that peak before, and then we have this peak over here, and that's probably about 402. So what you need to do is you need to take the information from the from the food colorings and the copper 2 sulfate, and then look at the sports drinks again and decide what kind of dyes are in each one, and then write that up.